part of programming and look at how we define our own functions in Python. Of course, we've been using lots of functions, and I've even in some of the notebooks defined some functions, but we haven't really looked at what the details are. But example functions we've used so far are length, which returns the length of a collection, type, which returns what type of object, input returns a string typed in by a user, math square root. They all have something more or less in common, is that they are taking something in, a collection, a Python object, a prompt, and returning something as output. Some of these functions that we've used are defined in the Python core. When we start Python, they're all there automatically. Length, type, open are examples of such functions. Some other functions we've used are defined in modules, such as the square root, which is defined in math. And in another slide, we'll explore more why we want to break functions up and put them in different locations, that they're not just all defined there in the core namespace of Python. And I do have a note here, I'm sure I repeat this, that functions in Python always return a value. So that value might be none, which is a Python, is a specific Python value, but something will always be returned. Okay, so how do we define functions? So functions just are another example of a compound statement in Python. And the way this is my anatomy for defining a function. So all functions start with the keyword def. So by a keyword, I mean it's a word that can't be used in any other context within Python. So I have def, space, and then this is going to be some function name, not with the brackets. Then parentheses, and in the parentheses are going to be my list of arguments, and we'll go into this in more detail. I don't have to have any arguments. I can have a function with no arguments, but I have to have parentheses. And then we have the colon, which marks the start of the compound statement, the block of code, and then we have the lines of code that define the function. So let's look at this in more detail. Okay, like I said, def marks the beginning. Function name is the name that you're going to give your function. For example, hello world, raw input, square root. And then the args are the arguments of the function. So if we think mathematically and we're thinking of trigonometry, we'd have pi over 4, in this case, is the argument for the function cosine. So what kind of names can I give functions? So it's very flexible. It follows the same rules as variables in Python. Really kind of the only limitation is that the name must start with a letter or an underscore. We can have numbers in there, more underscores, but what we want to do is we want to just make names that describe what the function does. And although sometimes I'll have it like func1, func2, those are not good Python function names because they're not telling me anything about the purpose of the function. So there are a lot of naming styles around. What I tend to use a lot is referred to as camel case, where I'm combining words together and I have capitalization of the first letter of the next word. This is discouraged for functions in Python, and the preferred style for Python function is a word underscore word underscore word, etc. And here's an excerpt from the Python style guide, just emphasizing that point again. Okay, the parentheses. So all function definitions, again, include parentheses. And the parentheses contain the arguments. I can have 0 arguments, n arguments. I can actually even have a variable number of arguments, which I don't think we'll probably go into that, but we might in the class. Okay, so what are the characteristics of these function arguments? So I can pass arguments in two ways. The first is called positional arguments, and that's just that I have an argument 1 followed by an argument 2 and so on. These positional arguments must be provided and provided in the order specified in the function definition. Now this contrasts with what is known as keyword arguments. An example of a keyword argument function invocation would be, I have a function called func2, again a terrible function name, and the syntax for defining a keyword argument is the name of the argument, in this case my name, come on, let me stop typing this, my name equals, and then some value. And this value is going to be the default value. And here I have my name equals Brian, and your name equals Wendy. So the beauty of default values is that if I don't have to type the value, if there's a value that's almost always used for that function, then I can provide that as a keyword argument, and the user only needs to change that value in the rare circumstances where it's doing something different. So let's look at this in more detail. Here's a link to the Python documentation about positional arguments. Like I said, the order of these arguments is defined and important. So if I have a function, my function, that takes as an argument first number, second number, and favorite letter, when I invoke this function, I have to provide first number, second number, and favorite letter in that order. Here for keyword arguments, here's a link to the Python documentation. And again, here's my function 2, and this has a keyword argument, my age, which I've set to an integer 29, and skis, which I've set to a string, rosignol. Now the order of these arguments does not matter. So I can call my function 2 with skis first and then my age and then skis as it's defined. I can provide a value for my age and not a value for skis, and vice versa, or provide nothing at all. So let's look at that here. So I have my function 2, and it's going to return a string where I'm interpolating in the age and the type of skis. So here in the first case, let's just split the cell. You see I didn't provide any arguments to the function call, so the function used the default arguments I defined in that I provided in the function definition, and I get my age is 29 and I ski on rosignol. So let me split this one. So here I provided my age. So my age is 46. I didn't provide any value for skis, and so it uses the default value rosignol, and I get as a return value for my function, my age is 46 and I ski on rosignol. And let's just play with this one. So here I have my age is 18. We'll change this to head, atomic, and 19. So I get my age is 19 and I ski on atomic. And then finally, here I'm calling it in reverse order. So I'm providing skis first. I get that as the functional output. Now, you can see that when I defined the function, I have my age as an integer and skis as a string. Python doesn't really care what type I pass to it. Now, the function may not operate properly, but here I'm calling my function 2 with two integers, 45 and 37, and I get my age is 45 and I ski on 37. Now I could make this so if we look at my function, I'm doing a string interpolation, and so here I'm specifying that I have an integer, and here I'm saying I have a string. Now integers can all be represented as strings, but not strings cannot be represented as integers. And so if I come down here and I make my age equal to 45, then I get a, oops, say skis equals 37, then I get a format error that I'm expecting an integer and I got a string. Now when I called the function didn't care. It was just in that statement there. So I could put this return a dummy string, and then when I come down here, it doesn't care anything about what the type of variables that's assigned with these keyword arguments. Let me get rid of that. Oops. All right. Okay, so that's positional keyword. The other error that you see that I got is that when I did it like this, let's change this to 45, I got an error that a non-keyword argument after a keyword argument. So positional arguments, when I have a function that mixes up positional, or this is being used as a positional because I'm not saying which keyword argument it is, and so it assumes it's a positional argument. Positional arguments all need to be provided before I invoke any keyword arguments. Okay, in my schematic of a Python function, I have here a docstring. So let's talk a little bit more about what docstrings are. So it's a string of text describing the function immediately following the function declaration. And this docstring is what's returned by the help function or the question mark in IPython. And it becomes a very important and useful way of documenting your code. So a docstring is not required to define a function, but is very desirable. And in the assignments that we do, we will expect a docstring to be part of your functions, and you'll get docked points for not providing docstrings. So it's an opportunity to define what the arguments mean, what types you're expecting, etc., and explain the performance of the function. So here I've got an example function that does nothing. So it returns a none, it takes no arguments. But here I have this docstring that's describing it, and so then when I do the help, this is what gets returned. It's the string that I typed. Okay, okay, now the heart of the function are the program statements, the Python statements that we have that are going to do something in our function. So again, this is a block of code. The function definition ends when the indentation of Python statements return to the level of the line with the def statement. You don't have to have any statements. I actually think that you have to have something like a return. Experiment with that. Well, but you do have to have an indented block. So there has to be something in your code that's indented. So when Python parses through your file, it recognizes this is the block of code, and then it recognizes when you're out of it. So here I have a function 1 that takes a number. This function takes a number and returns a 1. And here we're taking a number and we're defining a local variable b. We'll talk about the difference between local variables, global variables, etc. And it returns a 1. Now this print statement is part of the function. You see the indent matches everything else. This print statement will never be reached by the function because we'll always return before we get to it, but nonetheless it's part of the function. Let me split this. So I'm taking a number, I print 5. I'm printing, I'm calling function 1 with a value 4, and of course it returns a 1. Okay, here's a function that reverses the past string and returns it in uppercase. So string reverse and capitalization is the function name. It takes as an argument a positional argument, a string. I'm telling the user that I'm passing in a string through the docstring. This isn't a very well formatted docstring. I'm converting it to upper and setting that equal to temp string, and then I'm reversing that string with slicing and then returning that value. So if I pass in Brian Chapman, I get nampak narib, as the reversed function. And you see that I'm putting all sorts of different things in and getting the same string out, in this case because of what I'm doing with the capitalization. Okay, let's look at another function. Actually, we're gonna skip this, and we'll talk about the scopes in another slide. Let me just come down here. Let's do an example function. So I have a task: create a function that returns the value true if a uniform random variable is less than the function argument b, and returns an error message if b is not in the range 0 to 1. Now, as I've set this function up, it's bad function style because in one case I'm going to return a true or a false, and in another situation I'm going to return a string. And a better approach to this will be exceptions, and we'll handle that later. So here I have less than random. It takes as an argument x. My doc string is telling the user that it checks whether x is less than a uniform random variable 0 to 1. And if x is less than 0, x is greater than 1, we're going to return an error message. Here's the error message that we return. Otherwise, we're just going to return this this Boolean question. So let's look at this. Enter a number between 0 and 1. I can do 0.5. I get false. I can run it again. I get 22. I get my string message. X must be between 0 and 1. We'll just test that with a -9. And one last case, let's just do 0.999. False. Okay. So, and then we could do composition of these functions. So here you see I'm calling the input function, and the input function, the output of the input function becomes the input to the float function. We could actually just put this all in one line here. Just deleted something that I didn't want to do. And my function performance is the same. Okay, and now here's one more example function. So write a Python function for the following mathematical function. So if x is less than b, then I'm going to return e to the a x minus b. Otherwise, I'm going to return 0. So here I'm defining my math function. I don't have a doc string. I'll get docked for that. It takes as a positional argument x, and a keyword argument a with a default value of 1, and a keyword argument with default value of 0 called b. So I have within my block of code of the function an if-else. So first I test whether x is greater than or equal to b. If it is, then I return 0. Else, I return the mathematical expression there.